Okay, today we are solving quadratic inequalities, and we are, the front page here says that we're going to rewrite these inequalities in vertex form, and then after we've graphed it, we are going to represent the solutions in both interval notation and inequality notation. So here we go. We've got to transform the standard form into vertex form, so I'll go ahead and do that down here. X squared minus 2x, you got to leave room for your blank spaces here. Move your minus 3 to the back. He needs a blank space as well. Okay, once I have a 1 in front of my x squared, I'm ready to fill in the blank. So we're going to take half of negative 2, which is negative 1, and we will square that. Negative 1 squared is positive 1. Since there's nothing to multiply by in front here, 1 times 1, then this needs to be the opposite sign, negative 1. So 0 is greater than, so here we go, shortcut for factoring. We need an x and we need a squared on the outside, so this number here is half of negative 2, which is negative 1. And then at the end, negative 3 minus 1 more gives us negative 4. Okay, so this is the quadratic that we need to graph. The vertex here, opposite, so we need to go right 1 and then down 4. Right 1, down 4, so here's the vertex. Okay, so whenever I come up with my table, my original parent function table, 4, 1, 0, 1, and 4. All right, since we're multiplying by an a value of 1, there's an invisible 1 in front of the parentheses, the coordinates don't change. So from that vertex, we're going to go left 2, up 4. Make sure you're going 2 whole spaces and 4 whole spaces. Okay, we're going to go left 1 and up 1. We're going to, 0, 0 is the vertex, so it's the same thing on the other side, right 1, up 1, and right 2, up 4, mirror image on both sides. Now again, pay close attention if my line needs to be dotted or solid. Okay, in this case, my line is actually going to be dotted. It's not equal to. My line is dotted, and then we also need to shade. Since that's a greater than, we are going to shade up. Okay, so what that means is put your pen on the vertex and shade up, which means essentially everything inside the parabola. So what we're going to do now is we're going to identify interval notation and inequality notation. Okay, so what I want is the interval notation is you're giving me the coordinates looking at the x-axis only. I want to know what is shaded between where and where. So in this case, now remember, this is not equal to, I should have actually left these open circles, because since it's a dotted line, these are actually open circles. They're not filled in. They are not equal to. So the only thing on the x-axis that is shaded is everything in between negative 1 and positive 3. So negative 1 to positive 3 are the x values that are shaded. And since it's not equal to, these should actually be open circles. We represent that with parentheses. If it was a solid line, okay, if it was equal to and it was a solid line and they were closed circles, then here I would have brackets. So now to inequality notation, my x values that I shaded are in between negative 1 and 3, so I need to put my x in between the negative 1 and the 3. And if you remember, these always need to have less than signs. And since those are open circles, neither one of them are going to have an equal to underneath it. Okay, so my shading on my x-axis was in between negative 1 and 3. And then inequality notation is represented right here. Negative 1 is less than my x values that I shaded, but the x values I shaded are all less than 3. Okay, so let's look at number 2. All right, same thing here on number 2. We need to rewrite this guy into vertex form. Negative x squared minus 4x, leave a blank. Get your minus 3 in the back. He needs a blank as well. I'm not ready to fill in the blank yet because I need a 1 in front of my x squared. So what I'm going to have to do is I'm going to have to take a negative out. Now when I take a negative out, negative divided by negative is positive x squared. Negative 4 divided by negative leaves me with a positive 4x. And then I have my blanks there. Okay, so now I'm ready to fill in the blank. 0 is less than negative. So I got half of 4 is 2. And when I square 2, 2 squared gives me positive 4. Now, before I fill in the other blank, I got to distribute. 4 times a negative is actually negative 4. So this guy over here needs to be the opposite of that. It needs to be a positive 4. So I have my GCF of a negative out front. Let's go ahead and use the shortcut for factoring right here. This is x. Half of positive 4 is positive 2. And then here at the end, when I combine those like terms, negative 3 plus 4 is positive 1. Okay, so there's my equation. The vertex here, we're going to go the opposite. So opposite of plus 2 is a minus 2. So we're going to go left 2, and then we're going to go up 1. Make sure you actually go 2 spaces in 1 space. There's the vertex. Okay, now we'll take that original parent function table, as always, 41014. Okay, and we're going to multiply these a values, or sorry, we're going to multiply the y values times my a value. In this case, it's a negative 1. So if I multiply all these guys by negative 1, 4 times negative 1 turns into negative 4. 1 times negative 1, 0 times negative 1, 1 times negative 1, 4 times negative 1. So plotting those coordinates from our vertex, we're going to go left 2 and down 4. Left 2, 1, 2, 3, down 4. Left 2, down 4. Now, since, oh sorry, this one actually does have an equal to underneath it. I was leaving that out all along. This does has an equal to underneath it. So all these dots are going to be solid. They're going to be filled in. From the vertex, I'm also going to go left 1 and down 1. Left 1, down 1. It is equal to, so it's a solid dot. We're going to skip that. We're going to go right 1, down 1. And we're going to go right 2, down 4. Mirror image of each other. So again, connecting all these dots, we do have an equal to. So these dots are going to be connected with a solid line. And last but not least, we need to shade. Okay, so my shading here is greater than, and if my shading is greater than, that means we're going to shade up above the line. So put my pencil on the vertex and we shade up. Actually, in this case, that means we're shading everything on the outside of this parabola here. So when I'm looking at interval notation and I'm looking at inequality notation, okay, what I want to know is which part of the x-axis is actually shaded. Okay, so the x-axis is shaded everything to the left of the negative 3 and everything to the right of positive 1. This is an OR type problem that we saw in the first semester. So interval notation, we have 2 sections here. We go from negative infinity all the way to negative 3. Negative infinity to negative 3. Infinity, remember, always gets parentheses. And since the negative 3 is filled in, he gets a bracket. But that's not it. So you got to tell me, but wait, there's more. There's another section that's got shaded over here from negative 1 all the way to positive infinity. Again, infinity always gets parentheses, but my negative 1 is a filled in circle. So negative 1 needs to get a bracket. Okay, so there's interval notation. Everything got filled in from negative infinity to negative 3. But wait, there's another section. There's more from negative 1 to infinity. Okay, now inequalities. These are my x values that are shaded here. Okay, so there's 2 sections, so I'm going to have 2 different inequalities. The first one, all these x values that are shaded are to the left of negative 3. So how we're going to write that is all those x values that are shaded, they are all to the left or less than, also equal to negative 3 because it's filled in. Okay, these x's are left and equal to negative 3. So less than and equal to negative 3. All right, but we got another section over here. So I need another section of inequalities. These x values that are shaded are to the right of negative 1. So those x values are all greater than, they're all to the right of negative 1. They're bigger than negative 1. So those x values are greater than negative 1. And also, since it's filled in, it's equal to negative 1. Okay, so there's my inequality and interval notations there. In the next video, we'll do the same thing, except we won't write it in the vertex form. We will leave it in standard form, and we'll use our negative b over 2a in order to graph our vertex and graph our quadratics.